Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd Hamidi, MA19314.
Assalamualaikum warahmatullahi wabarakatuh. My name is Lutfil bin Riduan. My matric ID is MA19300.
Assalamualaikum warahmatullahi wabarakatuh. My name is Razwan Alif Rohaizi. My matric ID MA19306.
We start our presentation with the introduction of Thermal Headgear. COVID-19 is significantly impacting our daily life as the deadly virus causes many sectors such as businesses and education to cease operation. There are many symptoms of coronavirus illness such as fever, which is the body temperature of people is 37.5 degree and above. In order to reduce the spread of coronavirus, we are going to design a high-tech headgear which can be used to detect body temperature easily and efficiently.
For methodology, I will show you our Gantt chart. For the week 8, we received our project from lecturer and first meeting with group member. And for the week 9, we discussed the tool needed to design. And for week 13, we designed the model by part. And for the week 11, we drawing the part using SolidWorks. For the week 12, assemble the part using SolidWorks. And for the week 15, presentation date. And lastly, for the week 14, final report submission.
So this is the method of drawing thermal headgear. The first part is the frame of thermal headgear. Firstly, we select the front face out to draw a rectangular shape with dimension of 146mm times 46mm. Then we extrude the sketch by 10mm. This part is about making a hole to place the glass. We just need to select the front face of frame and convert the surface to entities. Then we make an offset from the surface line about 6mm. Then we use extrude cut to make the hole. Then we create a new plane at the center of front face of the frame. Next, we draw a line following the line of the hole. After that, we use 3D sketch to draw a rectangular shape. Then we use shortcut to make a groove to place the glass. Next method is we make a hole about 5 times 20mm at the side of the frame and extrude cut until the other side of the frame. After that, we make a fillet about 5mm or 2mm at every sharp corners to prevent possible defect during manufacturing process of this frame. Lastly, we make a groove to slide the thermal camera at the side of the frame. The next part is drawing a strap from the frame. We just need to draw a curved shape. Then we use the sweat boss according to the line. Then we change the material of strap to rubber. Next is drawing the glass. The dimension of the glass should follow the dimension of the hole on the frame. Then the part is changed into a glass material. We should make a groove to place the display camera on the frame of the glass. Then thermal display. Just draw a rectangular shape with same dimension of the groove on the glass and extrude it with 10mm. After that, a circular shape at the front face of the part and extrude outward with 20 degrees. Create one more smaller circular shape and extrude about 3mm with 20 degrees and change the material into a glass. Finally, change the bigger circular extrude shape into a rubber. This is for thermal camera. After that, the method of drawing the thermal camera is a bit same with the thermal display. The last part is the battery case. The method is just using an extrude boss and shell the part. Create an offset line and use extrude cut. Then we draw the terminal for the battery. For assembly method, just insert all the parts, then select an advanced mode and select width and choose tab selection and width selection so the part will be placed at the center of other parts.
Discussion. Based on the final design, the user acquires the ability to detect the temperature of any object just by looking at it. The design functionality are basically decrypting the visual of the thermal camera to the thermal display. For the ergonomics, it provides the ease of utilities since it uses rubber strip and extendable battery, other than focusing on reducing the cost. This would be very useful to this current situation because it reduces the waste of time and energy for using it. On conclusion, we are able to know more about SolidWorks software, learning the inside out of how to use SolidWorks software, able to design a thermal headgear model using SolidWorks software, hoping that using our design to help frontliner to detect body temperature of people in larger crowd.